Okay, welcome everybody. My name is Benjamin, and we'll be talking a little bit about some of the things that were already touched upon by Robert in his keynote. For those who attended the session right before this one in this room, you'll also recognize a couple of things, but let's not get ahead of ourselves first. So first of all, I'd like to put a couple of questions. So I'm wondering, who amongst you uses email every now and then for your daily business? Who amongst you is every now and then has to write a report for your manager to read, or get some reports from gets a report from your reports to read? Who amongst you sometimes listens to customers? Who amongst you would still get paid if you didn't do any of that? Okay, yes. All of those activities are things that you do with unstructured data. All of those activities involve reading or writing text that is produced by humans. And that is, okay, it was a little bit of an extreme example, obviously, but it really is crucial to doing business. It's crucial to kind of being around and interacting with other people that you use unstructured data, that you use language to express yourself. What sets us apart from computers, not from animals, is that we can use text to express ourselves, and not just kind of measurable facts that are produced by an algorithm or produced by a sensor that reads something. If text is naturally always written by a human person, and thereby always kind of carries some sort of an insight or an opinion or some conclusions or some kind of personal thing from the author, and therefore it has more meaning than if you would just have seen the raw numbers. So that's so unstructured data is really very very important, and it's pervasive. So we'd better try and find the best way to treat it. Unfortunately, the single best tool to deal with language is the human brain. And if you are working in an environment where there's lots of reports and lots of email, you would sometimes wonder, is there a way that I can avoid having to read through all of this before I can consume all the information? So what we'll be talking about in this session is tools that will help you deal with that unstructured data, that will help you kind of consume that. So the second best option after the human brain, which is software. So we'll be talking a little bit about unstructured data. There we go, and we move. So let's imagine that you live in a country that's going to the polls in the near future. So if you are a presidential candidate in that country, you are probably interested in what the people are saying about you, or what the press is writing about you in newspapers, or what they're saying about you on television. So maybe you are very rich, and maybe you can employ people that will read every newspaper and put post-its on the pages that mention you. Or maybe you can ask them to watch every news channel and then kind of filter out the pieces where you are being mentioned. But that is kind of a labor-intensive process. So there are tools that do exactly that, that kind of identify in-text names of persons or names of places. So those tools are what is called named entity recognition tools. And for example, Alchemy API is a tool that does it. OpenCalais, Prospero, Themis, and a bunch of others are tools that are dedicated to just one thing, identifying persons' names. And sometimes they will also give you back like a reference that tells you whether that was who the person is, and referring to some sort of an online unique identifier on DBpedia or a link to Wikipedia, and so on. So that's named entity recognition. Very useful thing, has a couple of very valid use cases, and there's a couple of nice tools that do a very good job at that. Imagine working for a healthcare company. Anybody in the room who's working in a healthcare-oriented organization? Wow. So as Joe already put it in his keynotes, working in healthcare, even though you may be writing software, your end goal is to save people's lives, is to make sure that they get better and that they have a happy time after they have been treated for something that wasn't as pleasant. But all of that is obviously going through software. So you want to make sure that the software that you are writing is kind of servicing that end goal of keeping people healthy or making them healthier. So you want to make sure that you can consume all the data that is necessary, all the data that is available to kind of improve that outcome. Unfortunately, clinicians are humans, and they don't write just numbers and diagnosis codes. They write text. They write natural language text, or they just dictate it in a microphone. So to be able to interpret what is in an electronic medical record, you also need tools that are able to kind of understand doctor's language and identify what are signs and symptoms here. What is the mention of a certain medication here? So there's also definitely a market for tools that are specific to the healthcare market and can identify relevant pieces of information that can extract clinically relevant facts from text. So there's a bunch of tools that do this. For example, Apache CTakes is one example. Nuance has a lot of software that works towards this. In our HealthShare product range, we're also working on a module that will help you extract clinical information. So that's yet another use case of yet another type of tools that is oriented to extracting information from text in one particular environment. Now, a third example is when you don't want to look for specific things, perhaps, but you're more looking to really understand the data. And I'm not sure, Danny, is your session still on tomorrow, turning your accountants into explorers? Okay, so you'll have to watch the recordings if you want to see another example of that. But so in Danny's session, we were working on a project that Chris also works on, where we're trying to interpret investment management agreements in a finance scenario and try to kind of automatically infer investment rules that are in that legalese text so that these rules can be enforced when you are trading. When you are I'm buying 5 million, a 5 million position in this particular company, but that company's profile doesn't match certain criteria expressed in these 200-page investment management agreements, well, then there's a red light that starts flashing. So that's another scenario where the goal of the tool is really to kind of interpret the language and kind of find out what is the structure that we can infer. For the people who were in Misha's session, this is what the merge type of tools is very good at. So Stanford NLP and I know is also really about understanding the language, not identifying particular things, but understanding what really was being described in the sentence. And there's more specific subtypes of understanding language. For example, trying to understand sentiment in text. So that's yet another type of tools that are dedicated to a particular way of working with text. Now, there is kind of a problem. Any people in here in the room that develop solutions? If you are developing a solution and you need to combine several things, so for example, you want to make sure that you cannot tell your presidential candidate that, okay, you were mentioned in this and this and this newspaper, and you were mentioned in this context, or okay, I found this sign and symptom, but it was in a negative context, or these were the things that were related to it, or it was in someone's medical history, or it was in the family history, different things. So trying to combine those tools can be very challenging. And the main reason for that is that these tools were written by very diverse people, by a very diverse set of roles. So for example, Prospero, an example of a named entity recognition tool, was written by a bunch of political scientists in France. I'm not going to make any comments about the beauty of the design or the interface, but it wasn't a bunch of developers. So it's a point-and-click application that has a couple of set functions. If you look at the clinical use case, Nuance is a big company. They have a whole suite of solutions, and the particular tool in there that identifies clinically relevant information is part of that suite. And obviously, Nuance's ambition is to make sure that they can sell the entire suite, so including the dictation stuff, including all the other components that are part of of that suite. So it's an entirely differently architected solution. And then Stanford NLP is written by people from Stanford. So it's an NLP tool written by computational linguists for academic purposes. So it can export to XML, and then you can publish papers about it. But it's an entirely different kind of perspective with which it was written. So if you have to develop a solution that combines more than just a single tool, or even a single tool, it can get very challenging to kind of work with the output or give it the right input in a convenient way. So not all of these tools were really written to be reused and leveraged, despite the fact that they may be extremely good at their respective use cases. So wouldn't it be nice if there would be some sort of a unified information management architecture? Well, guess what? It exists, and it's called Unified Information Management Architecture. It's a standard. It was originally developed by IBM as part of the inner bowels of their Watson solution in order for them to be able to leverage many different NLP tools as the foundation, as the very start of that huge Watson architecture. But then IBM open sourced their implementation, so the standard is being maintained by Oasis, and in the Apache Software Foundation has the reference implementation, which is implemented in Java. So that is a standard, and that standard kind of tries to address what I just described, tries to address the fact that many of these tools have a completely different architecture and are difficult to integrate. Well, UEMA tries to make sure that you can work around that. So let's take a closer look at the main goal of UEMA, interoperability. And funnily enough, interoperability was also at the top of the list of the characteristics that Terry gave for what we are doing at InterSystems, what our software attempts. So UEMA is a standard that expresses what a text processing or an unstructured data processing component should do. And UEMA calls that an analysis engine. So the standard says for the NLP developer, for the linguist, for the political scientist, for the clinician, nurse, technologist in the hospital, they give a contract, they give an interface, and you need to implement that interface. And you can do whatever you want. You can choose other technologies, as long as you kind of take the input that UEMA says you are going to get, and you give the output that UEMA asks you to provide, you're fine. And if you are a solution developer on the other end of the fence, at the other side of the fence, you can just work against the standard, and if it turns out that there is another component that may be of use, you can just plug it in, and you don't have to change your application because you're working along the standard. Anyway, that's the point of a standard, isn't it? So a couple of examples of tools that are available in this area is Alchemy API. It was recently acquired by IBM. Not so recently, but the last 1.5 years. So that's this NER, that's this named entity recognition tool. They have it's originally written as a software as a service, so it's a REST service that you can call. But they also have a UEMA wrapper around it, so that you could, in your UEMA workflow, just call out to Alchemy API. Apache CTEX is kind of a bundle of a large number of individual analysis engines, some borrowed from other open source projects. But together, they aim at extracting clinically relevant information from text. So this is actually a very broad library of components, but all implementing the UEMA standard. Ruta, rule-based text annotations, is a kind of a sub-project of UEMA itself that allows you to kind of build rules to combine different annotations that may come from other analysis engines. So you can kind of build rules and say that, okay, if I come across Donald Trump as an Alchemy API annotation, and then if I come across big hands as kind of anatomy parts in my Apache CTEX bundle, then I'm going to highlight this as a news headline, a new annotation. So those are the types of things that you can do with Ruta. So let's take a closer look at what it actually means using an analysis engine. So it could be a completely black box. You don't know how it would be implemented, but you put text in and you get the same text back out with annotations. So the text doesn't change. It doesn't put XML tags in between, or it doesn't do anything. Your text is immutable, because Only if your text is immutable, you can chain multiple components and have the same end result, obviously. So every analysis engine will just add a couple of annotations. It will refer to your text and say, from this character position to this character position is a person name, and from this character position to this character position is an anatomical place, body part, whatever thing. So that's what an annotation is. It's start position, end position, and then some metadata, sometimes very complex metadata, but just metadata. And again, so these could be completely different technologies, completely different vendors. As long as they implement the contract, you're good. So the standard is actually a little more complex than that. It offers a little more variety, and it's not restricted to text only. So you could also deal with other types of unstructured data. For example, you could picture an analysis engine that extracts the audio part of a video fragment. So the input would be, the input document would contain one stream of video, and your first annotator would then identify the audio and add that as a second stream of information in your same document. But it's immutable. It just adds something new on top. And then a second analysis engine could do some speech to text, translating whatever is being said on the audio track into textual information. So you get a third stream of information, a third view on the same original document. And then a third analysis engine could then do the regular classic annotation types of things as we saw earlier and identify in the text and then add its annotations to the text. So rather than character positions, these two will probably do their annotation work with, for example, second offsets. So from second 1 to second 2, there is a song, very short song, but anyhow. So that's the idea of interoperability that UEMA brings to the unstructured data world. It does more. UEMA itself already contains some features to allow you to scale up. But you can't expect your NLP developer, your political scientists, your clinical technologists to be extremely good at writing software that can deal with multiple cores and that can make sure that you maximize throughput. No, those people have skills in a particular unstructured data treatment area, and not necessarily in kind of optimizing performance and making sure that your pipelines can be parallelized. So that's also something that the standard can take care of. And again, we're at another part of the theories for characteristics. So UEMA also can give you scalability. Because it's all standard components, the standard can also kind of abstract how often they are being invoked or how they are being invoked. And there's an extension of UEMA that is called UEMA asynchronous scale-out that kind of automatically creates instances of your analysis engines and adds them to a pool, and then puts queues in between every pool, and then so you throw in 1,000 documents, and they get processed by pool of annotation engine 1, and asynchronously they are being pushed on the next queue for the next pool, and so it just spreads out the work over a single machine or over multiple machines. So it really allows you to parallelize all the work thanks to this standard, and it's fully transparent for the analysis engine developers, and also the solution developers just have to kind of use an additional descriptor file that says how many should be in your pool, and do you want this to be instantiated on a different node, and so on. So great. So we already have two very important advantages, very important benefits that this standard brings. Now, all good things come in threes. However, with UEMA, not the case. UEMA has a bunch of other advantages, but there's also one big disadvantage that we see for solution developers. If you are a solution developer and you want to develop something that allows people to analyze text, well, then after you've processed your documents, you would like to store that output. Well, the UMass standard is a processing standard and doesn't say anything about storage. So the UMass standard ends here with that document. So you can get it out in memory structure, and then you can serialize it into an XML structure, but that XML structure is extremely verbose, and you can't really query that. So great standard for processing text, but it's for solution developers may want a little bit more. So we would like to kind of fill that void. So thus far, I've been talking about the standard only and nothing specific to InterSystems. So now let's take a look at what InterSystems wants to add to this standard. We're not going to extend the standard itself straight away, but we're going to add add meaningful capabilities for people that choose to use our platform and want to use unstructured data processing as well. So first of all, we want to give you a more intuitive, a more simple API to deal with UEMA analysis engines. The UEMA standard, the Java interface that you should work with is not overly complex, but if you are a happy InterSystems customer, any happy InterSystems customers here? None, damn it. So you may be happy with your cache object script, with your tables in cache, and you may not be looking forward to starting to call out to Java and do all that plumbing work. So we're doing the plumbing for you. We allow you to define what is called a functional index on a table, and we will take care of forwarding the information that comes into the rows that are being added to your table to forward the text into the Java environment that UEMA is. And next to that, obviously, also some kind of a direct way, like a $system.uema index now method that immediately gives you results. So that doesn't require you to store the results or have it stored in a table. So just a bit of convenience stuff. So not extremely spectacular, but it's making it much more easy and much easier for you to kind of get started. And I'll show you in a minute how it looks. And then second thing is that big void that I mentioned that is at the end of the processing pipeline. So what we're adding, or what we're complementing the standard with, the standard for processing, is a kind of standardized annotation store. Any sort of annotation that comes out of a UEMA compliant system will allow you to store that in a cache database that is easily queryable, that is nicely indexed. You can tune it a little bit. You can query it with SQL. You can query it with REST. You can, in a future version, query it with the Document API. And it has all these annotations next to one another. So whether it's INO annotations, CTAKES annotations, Alchemy API annotations, they're all sitting nicely next to one another, and you can combine them in analysis or logic that you want to apply on top. And then third, last but not least, we want to make sure that people who want to use UEMA can also use INO as part of their UEMA workflows. So for those of you who are not very familiar with INO, INO is our own NLP technology that uses a unique bottom-up approach to understand language. We do not understand that finger is part of a body, or that pale is possibly kind of an indicator, pale and having high body temperature is possibly kind of an indicator of sepsis. But we will know that if there's a sentence that says patient had a higher temperature and was looking pale, we'll be able to identify that higher temperature is a concept that's important in that sentence. So we understand language, and we'll give you kind of a parsed form of your sentence that contains the concepts as the text author wanted to say. So that INO has been available for a while in InterSystems software. It's been available through a bunch of APIs that allow you to work with domains where you can put data in, or it has been available through iFind as another functional index that allows you to implement search and at the same time leverage the output. Now we're also making sure that that unique INO engine that we have is also available for processing in UEMA workflows. So that's a bit of an overview of what we at InterSystems want to add to how we want to make UEMA a core part of our platform. So let's see if we can see this in action. Any questions thus far? Because I've been rushing through. That's at least what the clock is telling me. Okay, let's first go and see what it looks like. So let's first see the code. I'm going to do it in Studio. I refuse to use Atelier until Robert and Bill can pronounce it properly, as the French do. No, I just was a little late in giving it a try. So what have we got here? So we've got a regular cache class. Is it readable? Because the resolution isn't superb, but okay. So I've got a cache class, and I have a property called txt, very revolutionary column name, that contains text. And I want to index that text. I want to apply my Uima workflow on top of it. So here I've defined ctakes, an index called ctakes on txt, and then this is the bit of syntax that's specific to functional indices. So you define an index class, and in this case it's %uima.index. I give it a couple of kind of resource identifiers, because ctakes needs to use a couple of files, and then I point to the descriptor file that says what the capabilities are of my analysis component, and that says what class it's implemented in, and I can open that one right here. So here's let me maximize that. Is it readable? It's not too important, but anyway, so this is the descriptor file that comes with every Uima compatible analysis engine. So it says whether it was a Java-based or a C++-based component. It says whether it's a regular standalone component or whether it's an aggregate, so like a combination of other components, so you can nest one in the other, and then it points to the actual implementation class, and then there's a couple of other things like parameter settings. So for example, this is the one that's going to call out to the Alchemy API service, so you need to have an API key. Please don't copy this. Type system, so what are the types of annotations that are emitted by my component, so what's the information that we can get out of. So there's a bunch of metadata about your component that's part of this standard XML file. And the only thing that we need to do to use Uima is point to that XML file and make sure that the code, the actual implementation, is accessible for cache. You could also combine a couple of analysis engines by just using a semicolon and add multiple ones, but I used separate ones because then I could kind of build the indices separately. Because then the only thing that you need to do in order to really invoke this is calling %build indices as if it were regular cache indices. So what does it create? Then it creates a table that contains these annotations. So let's take a look. So we were looking at our nets data. So this is the original table, and then so then it automatically generates, as soon as I compile the class, it will automatically generate an annotation table that says begin and end, so the part of the text that was covered. It has a calculated field containing the actual cover text, document ID, features, and the actual type. So I can open that table, and then it's going to show these are a bunch of the ctakes annotations. But let's do a couple of queries to show them in a more meaningful way, or give some more meaningful results. Oh, these are for the next one. Okay, let's first look at the results highlighted in text. So this looks a little nicer. So here is my document. This is a document that was part of that table that was indexed by both Uima. No, this is one that was processed by both Uima and Ino. So it's a kind of fictitious EMR record, and I can highlight the different annotations that came out of it. So here, there's about 20 different annotation types that come out of ctakes, and then there's a bunch that come out of Ino. So for example, I can highlight all the Ino concepts, and then here you'll see highlighted what I know identified in its unique bottom-up fashion as the concepts in there. And then I'm going to look for the more meaningful ones that come out of CTAKes. Where is it? Okay, so here, disease or disorder mentions, anatomical site mentions, and medications. I think those were the ones that I wanted to look at, or procedures here. Good. So, and now you can see a nice rainbow visualization that kind of overlays information coming from Apache CTAKes, an open source platform that was implemented completely independently of INO, and the results from INO that were the engine that was designed 12 years ago and has been constantly improved, obviously, but it was the two never really thought about one another. But the standard allows their output to be combined with one another. And here we can see how they really kind of add information to one another. Oh, this was the one I wanted to highlight as well. So it's probably a little difficult to read, perhaps in the back. But here, for example, we can see that CTAKes identified gross hematuria. So I don't know exactly what that means because I'm not a doctor and I'm healthy enough to not suffer from it. But it is so that this is something that was in some dictionary that CTAKes used to identify clinically relevant facts. Now, actually, what the author of the text wrote about was occasional intermittent gross hematuria. And occasional intermittent was not part of the CTAKes dictionary, but it also is relevant because it was part of the concept that the author wrote down. So this is an example of where you can see that it's useful to kind of combine top-down type of solutions like CTAKes with bottom-up sort of solutions like what INO does. So, and UEMA allows you to do that, allows you to really kind of combine them and overlay them in a visual way. Here's another one, like some lower lumbar aching. So for some reason, CTAKes was only interested in this anatomical specification and then this sign and symptom. But actually, there's a little bit of modifiers around it that are actually that may kind of make a difference in how this patient should be treated. Okay, so much for the CTAKes example. Then for the other one, I'm going to also show you. Yeah, this was developed by ISA. No, not at all. It's just a very useful component. So this is Alchemy API. It's as I mentioned, it's a RESTful service. You can just call it directly. So I'm going to send it my secret API key and a very long piece of text, and then we're going to see what the results are. And it comes back with the results, and it says. So it says a couple of things. It identified that it was an English sentence, and it gives a list of all the entities identified. So it identified a certain person. That's Obama. This person has a couple of characteristics. This is the kind of canonical name for him, and these are some online references that you can refer to. So this is pure named entity recognition. Alchemy API, like OpenCalais, is really good at that. They do exactly that. So very helpful. And it also points to the job title of this person. Oh, I think I should specify that there's a way how you can also make it return the occurrences, which is obviously what we wanted. I'm not sure. I'm just going to give it this one try. Occurrences. Is that written right? So send. No, probably it was some other option. There's an option that that is being called in the UEMA wrapper, obviously, that also identifies what the occurrences are that actually refer to this patient. So this actually is kind of a top-level sort of annotation. So this is what Alchemy API is. Now, if we want to call this as part of a UEMA flow from Cache, then here I have a table with a couple of New York Times articles. Again, a number of columns in there, and I created an Alchemy Index that points to my Alchemy API UEMA annotator. I've got one on INO, and then I've got my kind of cheat sheet. And also something, so there's a way how you can tune the annotation store that is being generated. So for example, you can tell it to extract a couple of features. So as you may remember from what we saw here, so all the metadata that your annotation contains is kind of condensed in a general purpose features column that contains JSON, that contains all the information that your annotator, your analysis engine identified. You can tune your analysis engine to put some of that automatically in another column. So for example, INO contains a normalized value, and Alchemy API also have sort of a normalized value, but it's just has a slightly different name. But we're going to just throw all of those into the same column, and then here's a few other kind of little tricks to extract particular parts of the Alchemy API. So you can really tune your environment. You can add additional indices to it. You can only filter particular types of only include particular types of annotations. So let's take a look at our at the results here. So okay, let's first do the annotation viewer. So here we again see a piece of text. I can highlight what INO identified as negations, what it identified as concepts, well, and then also overlay that with the output of the Alchemy API, where it identified North Korea, Kim Jong-un, and a couple of other places and persons, and so on. So now if you want to query that table, let's do a first one here. And now here, for example, what this query will give us is an overview of all the different entities that Alchemy API identified, and then what the corresponding INO concepts were. So some of these were some Alchemy API entities only occurred once as an INO concept, but some appeared many more times. And there you can also see what the difference is between what the job that Alchemy API does, like a top-down approach to identifying particular things, and what INO does, the bottom-up approach of identifying what actually is being referred to in the text. So, for example, here, it's not the most spectacular example, but this is Beijing is the place name that Alchemy API identified, and Beijing's leader is the actual concept. So if you are writing a tourism application, then maybe you weren't so interested in a concept that says Beijing's leader as much as if it would have said just Beijing, as the author was talking about. So that it's maybe not as stark a contrast as with the clinical examples we saw earlier, but you can see that there's a difference, and you can nicely get that out of these of this kind of shared annotation store. So let's do another query. So this one is slightly simpler. So this is actually just an aggregation of the previous one. So this will tell you for every Alchemy API entity what are the number of concept references in the text that INO has identified. And then, oh no, it was not. It had nothing to do with INO. It was just how often every Alchemy entity was occurred. And then here we're kind of going a bit of a step further, and we're going to combine the results of UB. We're going to combine the Alchemy API results for I think we're looking for China or North Korea, which was the search term for which I extracted all this data. So from the New York Times website. So here we're looking at the INO concepts that INO identified as being related to the INO concepts that we saw earlier that corresponded to the Alchemy API entity. So if you are looking for, so for example, I didn't have data on Donald Trump, but if you are working in Donald Trump campaign team and you would you can use an Alchemy API type of named entity recognition tool to identify all the mentions of your favorite politician, and then use INO to identify what is the context, in what context is this person being referred to. And then you'll see the results with with a proximity ranking that shows you how closely related they are. So that's yet a third way of how you can use this annotation store and how you can query the annotation store and get some insights out that you couldn't have gotten by looking at using just a single NLP tool. The combination of these NLP tools is really what makes it very interesting. So that was, in short, what I wanted to say about the Umass standard and what InterSystems is doing to complement this standard. So it's a standard that already provides interoperability and scalability, and what we're adding to that is a more intuitive API, is an annotation store that you have a persistence option for it, and we're making sure that INO fits in that same package. And maybe one last thing that I didn't explicitly mention, we're also striving to have an open platform. So whatever we are doing here for UEMA, in, for example, that annotation store, we do not ask you to first put all your data in a cache table. You can do so and then take advantage of the UEMA index. But if you already have a platform that's based on the UEMA standard, such as what Themis has, another French company, then they can also use our annotation store. They can also just use the little kind of analysis engine endpoint that we implemented, because it also fits the standard and it just writes it to our database. Okay, any particular questions? Okay, this is, yes? I was literally going to say that. This is not available at this time. This is currently part of one of the new technologies, such as the horizontal scalability, such as the Spark integration that Robert referred to, and a bunch of other kind of things that are more looking into that are going to be part of a next generation of our software. So I can't give you an estimate on when this will be available. There's probably going to be a way to get access to this and give this a try still this calendar year, but I can't say that it's going to be this particular version number of this particular product. But if you have a use case for this and you would like to pursue this, we can see what's the most convenient way of making it available. Any other questions? Okay, then thanks a lot, and off to lunch.